Hello everybody, my name is Danielle Fopp and today I will be taking you through the technical appraisal lecture for project appraisal. So let's start with a definition. Well, technical analysis or technical appraisal, you'll see the two used interchangeably in textbooks and readings. Let's have a look at the definition for the project appraisal. We have a technical analysis represents the study of the project to evaluate technical and engineering aspects when a project is being examined and formulated. It's really important that we don't confuse this with its definition in finance, which is a technical analysis is a financial analysis that uses patterns in market data to identify trends and make predictions. We will not be using technical analysis for financial analysis. We will be using the technical analysis for evaluating the technical and engineering aspects of the project. So let's jump in with the when, who, and how. So when, as early as possible, and also review continuously throughout. And we will see it is imperative that it is done as early as possible. It's one of the critical appraisals. It's completed generally by technical personnel, plus it also requires a review from a second team. And how? Well, we assess the technical aspects of the proposed project, and what is key is allowing for contingencies. So we'll jump into this in a little bit further detail as we go along. Let's take a look at some key aspects of the technical appraisal. So we have the selection of the process or the technology to be used in the project. For manufacturing a product, we know that there's generally more than one process or technology which may be available to achieve the same outcome. For example, steel can be manufactured either by the Bessemer process or by the open health process. Cement can be manufactured either by the wet or the dry process. The choice of technology also depends upon the quantity of the product proposed to be manufactured. If the quantity to be produced is large, mass production techniques should be followed and the relevant technology is to be adopted. The quality of the product depends upon the use to which it is relevant for the client, and that will also influence the technology to be adopted. A product of, say, pharmaceutical grade or laboratory grade should have a high quality, and hence sophisticated production technology is required to achieve the desired quality. Products of commercial grade do not need such high quality, and the technology can be chosen accordingly. Now, the term appropriate technology refers to technology that is suitable for the local economic, social, and cultural conditions, along with those output requirements of quality and quantity. Then we might look at scale of operations. So the scale of operations is signified by the size of the plant, and that mainly depends on the market for the output of the project. The economic size of the plant varies from project to project. However, for any given project, it can be arrived at by analysis of the capital and the operating costs as a function of the plant size. It's really important that it's analysed carefully, as whether the project will survive at the proposed size will depend on the scale of operations. Then we're going to look at the raw material. So a product can be manufactured using alternative raw materials or with alternative processes. However, the process of manufacturing may sometimes vary with the raw material chosen, and it's important that if a product can be manufactured by using alternative raw materials, that alternative raw material is locally available, and this will help us with reduction in transport costs and things like that. Another key aspect to be considered when looking at your technical appraisal is whether the technical know-how for the project can come from within the company or whether it's going to be provided by expert consultants. So it must be ascertained, if going to a consultant, that they have the requisite knowledge and experience and whether he or she has actually executed similar projects like this successfully. So you want to make sure and be really careful that you don't end up with inexperienced people in this area of project. We also then have the selection and procurement of plant and machinery. Now, the machinery and equipment required for a project depends upon obviously the production technology proposed and also the size of the project. We also then need to look at the capacity of each machinery and decide what's actually going to be suitable. So, for example, in construction operations, we look at the sizing of cranes. So that would be one such item that you would be looking at. Do we actually have the capacity of machinery to complete the project? To do this, we also take a look into the consideration of the output planned or the size of the project. We also need to look at the machine hours required for each type of operation, the capacity required, and also making necessary allowances for if there's a machinery breakdown or if someone needs to go into maintenance. Workers need to be rest, set up time for machines, time lost during change shifts, etc. And we also need to make sure that there is machinery available in the market, particularly if we're hiring the machinery, with regard to the capacity chosen, and it's equal to or just above the capacity theoretically arrived at. Then we also need to be looking at the fact that the quality of output of the project really depends upon the quality of machinery used. And so we need to make sure that there's uninterrupted production or construction during the project because we have timelines to be met along with the quality of the output. We then have plant layout, and I'm not going to go into that too much detail because we go into that in other courses, but we know that the efficiency of a manufacturing or construction operation depends upon the layout of the plant and machinery, and that it can be arranged at various production facilities and different production areas. We also then need to be looking at the location of the project. So at this point in the appraisal, the location would have already been chosen, but we need to make sure that we look at the location in regards to the machinery and the technical requirements of the project. So we're looking at the chosen region and the particular site which has been selected. So there's regional factors, and these will impact the availability of raw materials, of the proximity to market, of the availability of labour, availability of supporting industries, and then we have the site factors, which is what we discuss in other courses, which is, for example, considerations like cost of land, suitability of land, availability and suitability of groundwater if this is required, and so on. And there's many more. This is just some key aspects that we're looking at. So what are some of the risks which are normally associated with the technological aspects of a project? Well, these might be things like risky technology or new untested technologies, and that might be new and untested technologies globally, or it may also be new untested technologies for the firm or for the company. We also need to be considerate of badly established technology, or for example, if a company is using technology that just isn't working. There's also a very high risk, specifically in a lot of new projects, of underestimating the complexity of tasks or projects. We approach the project with a high level of optimism because we want it to go ahead. This is why it's important to have an independent appraiser come along and see, are we underestimating the complexity of the task at hand? There's also a risk for projects where they are frequently altering or changing the technical specification. Now, some projects do carry with them a high level of technical challenges, and those are generally projects that incorporate high levels of technical risk, full stop. So if we think about things like NASA or projects requiring difficult engineering innovations or complex transport structures that haven't been done before, or if there is a project built in a particularly uncertain geotechnical condition, this will have consequences for a major part of the project costs. So these are all projects in areas with high levels of risk. We also need to think about the risks of extraordinary weather or earthquakes if your construction project is in one of these zones. And then there's projects with other complexities and uncertainties concerning the reliability of cost and time of construction. And they're different risks that we look at in a different section of the appraisal. So if we come across a project with some of these technical risks, what does that mean for the project? Well, if we don't address it in the appraisal phase and flag it as something that needs to be addressed, it can lead to cost overruns, time delays, or poor quality of performance. So we're not saying that if a project has these risks, it shouldn't go ahead, but they need to be really properly appraised and assessed so that we can understand the consequences for the project. And that's your role as the appraiser. Okay, so we've identified that the project might have some risks from the technical appraisal. We know that if these risks are not addressed, it can lead to things like cost overruns. So what can we do to minimize the risk? Well, we know that when a project has any of these characteristics that we've previously seen, it's even more important to soundly evaluate the technical appraisal and assess as far as possible the risks associated with the construction and operation of the project. However, the following precautions can be considered. So we know that we should try to understand the technology before the project starts. So this would be your client would need to understand the technology before the project starts. We know we do not rush the design phase. This is why projects generally go through concept design, detailed design, sign-off. We know that we need to ensure that all staff are appropriately trained, and that also links in with the strategic appraisal with the matrix that we looked at, where on the left-hand side it was, well, what's the company actually able to do in this space? We need to ensure that the technology being used is compatible with the skill level of staff. So there's no point using a brand new whoop-de-doo technology that nobody knows how to use. We need to make sure that we get multiple opinions from others within the team and company. So if one person's saying, yes, I can do this, well, can the team do it? Can everyone do it? Then we need to avoid over-optimism in the assessment of risk, which is a really common factor that we see both in students and in industry. You want the project to go ahead, you're excited about it, you've seen the profits, you're like, woo! What we need to make sure is that we're not being overly optimistic and minimizing the risks. We need to be aware that we need to increase or change technology in small steps, so baby steps, as I like to say. We want to go for safer technology rather than the cheapest available. We also need potentially to be recommending the use of joint ventures, if appropriate, to assist in the transfer of knowledge and technology. So joint ventures are a great way if you have one company that's great at one thing and another company that's great at another thing. They can come together and complete the project together. We want to include industry experts in the project team, whether that's from the original company or whether they are coming in as consultants. We want to make sure that we are evaluating benchmarks and precedent projects with comparable risks. So what has the company done before with this level of risk? How did it go? What are we doing in this space? We need to include detailed information about the identified risk in any market sounding exercise or any stakeholder engagement that's going out for funding, particularly if we are searching for feedback of players in the construction industry or other relevant industries. Whenever relevant technical risks are identified, the best available resources should be spent in investigating further how uncertain they may be. And we looked at uncertainty earlier on in the course and deciding if the risk is tolerable without extraordinary contingencies. In all cases, further tests and investigations should be made so as to indicate to the potential financiers or to your client the parameters for their risk analysis.